Thank you very much, both Professor Ali and Oxygen Alto, for having me back here to Antalya. I was last here 8 years ago when I was president of the Society of Thoracic Surgeons, and I've watched this Congress closely ever since, and I applaud you for an absolutely superb meeting that you've had. So Professor Otto asked me to talk about innovation. And hopefully this is a talk that you haven't heard before and will inspire some ideas of the way to look at the world around you differently. So this is innovation in cardiology and cardiac surgery, and how does it happen? This is my conflict of interest disclosure. I've been involved in a number of randomized trials in the field of structural heart disease. So let me start by asking two questions, and I want you to think about them, and we'll get to answer them later on. Who invented TAVR and when? And I'll bet you don't know the answer to this. And who invented the MitraClip and when? Since this is Turkey, you may know the answer to this one. So let's talk about innovation. If you look at Wikipedia, which is the font of truth in the internet world, innovation is a new idea, creative thoughts, new imaginations in the form of a device or a method. However, innovation is often viewed as the application of better solutions that meet new requirements, unarticulated needs, or existing market needs. So innovation comes in many forms. This is innovation. Now you can argue it's for the better or for the worse, but this is innovation. And innovation is all around us. Just look at the last 10 or 15 years. The largest hotelier in the world owns no hotel rooms. The world's largest taxi company owns no cars. And the world's largest retailer owns no stores. 20 years ago, none of them existed. Anybody know what each of these individuals have in common? They're all cardiac surgeons who have invented something. And most of them invented a device used in transcatheter heart valve therapy. Surgeons inventing transcatheter therapy. So what's the path to innovation, and how do you get there? So I call these Bavaria rules after Joe Bavaria. You got to have a vision. You got to have a strategy. You got to have tactics to implement that strategy, and then you have to be able to execute it. However, distilled down to something more simple, this is Professor Frederick Moore from Leipzig in his presidential address at EX in 2016. His principles of innovation are as follows: 1% inspiration, 99% commitment. It's not enough to have a good idea. You have to have the commitment for the strategy, the tactics, and the execution. So there's a seminal work in the field of new technology called The Innovator's Dilemma, written by an author that's very famous in the business world named Clayton Christensen. And he divides technology into two distinct fields. First of all, a disruptive technology, which is a breakthrough, something new that's never been done before. And then sustaining technology, which are the refinements that occur after that initial disruption happens. And the value of the breakthrough is determined not necessarily by the original disruption, but by the refinements, enhancements that occur after the breakthrough. So let me give you a couple examples. This is the first portable communication that happened in the battlefields in Europe in World War II. 70 years of refinement in the portable communication have made it smaller, more mobile, more accessible, and now available on your wrist. So the original disruption was 70 years ago, or 75 years ago now, but the refinements have made it more usable. This was the original disruptive technology of recorded music. But look at the sustaining technology that's happened that's made it widely adaptable today. This was disruptive technology. This is sustaining technology that's evolved through the years to create the value to the original disruptive technology that we have today. This was the original attempt at human flight, and it was not a success. This was the first successful one, but look at the sustaining technology that's happened to get us to the advanced flight that we have today, the 737 MAX notwithstanding. So what is the path to innovation? First of all, comfort is the archenemy of change and a road to progress. We can never get too comfortable in the way we view things. We can't put our head in the sand and not look around as to the change that's happening all around us. I remember very well this article in USA Today in 1993 that panned the internet. The wireless net is so far wireless. Slow networks and sluggish demand hold services back, and it predicted no future for the internet. I mean, how wrong was that? Can you imagine a world without the internet today? But it was all the technological enhancements that occurred after the initial introduction that have created the value today. So, this quote from the British Parliament: "Good enough for our transatlantic friends, but unworthy of the attention of practical or scientific men, of Edison's invention of the light bulb." Television won't last because people will soon get tired of staring at a plywood box every night by a movie producer in Hollywood. I've had the opportunity of writing a lot over the years, but this is the most insightful article that I've written, and it was called "Minimally Invasive and Robotic Surgery." It was the millennial issue of JAMA that was published in 2001. Robert Guyton was originally invited to write this, and he said, "I don't know enough about this to do it. Why don't you ask Michael Mack?" So they asked me, and I didn't know enough to do it either, but I wasn't going to turn down an opportunity to put an article in JAMA. So I went to a bunch of consultants, I called them, which are cross-fertilization specialists in other fields, to ask, what is the future of surgery? What will it look like? And so I talked to general surgeons that perform laparoscopy, orthopedic surgeons, spine surgeons, urologists, plastic surgeons, cardiologists, industry, and entrepreneurs to see what they were investing in. And there were four themes that came through over and over again. Remember, this is 2000, almost 20 years ago now. And the future of surgery was ablation over excision. We wouldn't be cutting out tumors. We'd be ablating them with radiation therapy. Image-guided over visual. Reconstruction without suturing. And access by a natural orifice or blood vessel over incision. And I had a hard time picturing how this was going to be the future. 2 years later, the first human implant of a transcatheter aortic valve was happened. And I had never heard of TAVR, never dreamed about it. But if you look at it, it embodies three of those four principles: image-guided over visual, reconstruction without suturing, access via blood vessel over incision. So the advice of all these consultants from different fields was prophetic in terms of predicting TAVR. So don't be limited by what you think you know. I have made no apologies to myself for not having invented TAVR, because I, as a surgeon, I knew all the reasons why it couldn't work and it wasn't going to work. You got to cut out the old valve. Well, no you don't. You got to suture the valve in place. Well, not really. Well, all that calcium that you push aside is going to go to the brain. Well, maybe some of it does, but it doesn't seem to cause much problems. But I had a mentality that was such that I've never, you see so many things in your life, you say, aha, why didn't I think of that? TAVR was one of those things that I said to myself, I never, ever would have thought of this. So, who invented TAVR and when? And how did they do it? Anybody want to guess? Shout out a name. All right, I heard Alain Crebier, and that's what everybody thinks. So Alain Crebier implanted the first TAVR valve in a human in Rouen, France in 2002. This guy invented TAVR, not the guy on the right, the guy on the left. Anybody know who he is? He's a Danish cardiologist by the name of Henning Andersen, and his name is still known today because the Andersen patents are the intellectual property behind all TAVR. So I'm going to tell two back-of-the-napkin stories. You always hear about somebody invented them. They write it on a napkin, and then they get home and they file the intellectual property for it. These are two stories that's actually true. The Andersen valve was invented in 1989. Henning Andersen is a Danish cardiologist who went to a vascular surgery meeting, Ted Dietrich's vascular surgery meeting in Phoenix, Arizona in 1988. It's the time that endovascular therapy for peripheral vascular disease and aneurysmal disease was just beginning, and stents for large vessels were now just being invented and used in humans for the first time. So he said to himself, why can't you put a valve inside one of those and replace the aortic valve? And he literally sketched it out on a napkin on the plane home from Phoenix to Copenhagen. When he got home, this was arguably the first heart team working together in structural heart disease, because he went to the operating room to get his stent. These are surgical steel wires that you close sternums with. And he took it to his garage and he crimped them to be able to make the stent that he put this bovine pericardial, porcine valve on. He went to the cath lab where he took the balloon that was being used for balloon mitral valvuloplasties and performed the first TAVR experiment in 1989. So this is 13 years before Crebier did the first human case. He submitted his animal experience to Jack, and this is from the editor of Jack in 1990. As you can, I can read, you can't read. Okay. Read. I am sorry to have to reject it, but my overall rating is as too low a priority for publication in Jack. But he did file a patent for it, and this is the U.S. patent. This was issued in 1995. These are his initial drawings that he started on a napkin, and it looks remarkably similar to the TAVR valves that we have today, 24 years later. So he finally presented his results at the European Society of Cardiology in 1992. This was his poster, and it's remarkably similar to this poster, which was Grunzig presenting at the American Heart Association initial percutaneous dilation of coronary artery stenosis. And then it culminated in the first human implant in 2002. We got involved, and I was visiting in Leipzig at the time with transcatheter valves when Professor Crebier helped us do the first transapical valves at a time when the retrograde transfemoral approach had not been invented yet. This journey takes an interesting twist that 20 years later, this patient in 2011 received a TAVR valve. So what's so special about this patient? This is Dr. Anderson's father, who 20 years after he invented this valve, his father received the valve. He was declared inoperable at the time. And so how cool is that? How often in your life do you invent something that your own family member benefits from? So now we're in the middle of a TAVR revolution, and this past week in New Orleans, TAVR now has been shown to be at least equivalent to surgery in low-risk patients, completing this journey that Henning Anderson started over 30 years ago. So the point of all this is it's not like innovation happens overnight. This has been a 30-year journey to get to the widespread use of TAVR today. All right. Who invented the MitraClip and when? I'm sorry? This guy. That famous Turk, Mehmet Oz. Almost the same story. In 1997, he went to Milan to learn the Alfieri stitch from Professor Alfieri. On the plane back from New York, or back from Milan to New York, he sketched out the idea of being able to do this by a transcatheter approach, the Alfieri stitch by a transcatheter approach, and filed this patent, which was issued in 2004 to Mehmet Oz. So this cardiac surgeon, watching another cardiac surgeon suture the free edge of the leaflets together, invented the MitraClip. And indeed, he was an employee of Columbia University at the time. Columbia still gets royalties from every MitraClip implanted. So it's another 20-year saga. In 1998, it was first drawn out on a napkin. A company was founded, and it took a 20-year period of time before the recent COAP trial results showed a benefit in functional mitral regurgitation and published last fall in the New England Journal of Medicine. So this is an email that I got from Mehmet Oz an hour after the results were presented. Thanks for running a superb trial with remarkable results. I remember writing the patent on a flight home from Italy where Alfieri had just presented his initial results with open repair in 1996. After all the early effort to solve numerous puzzles and innovative approach, the New England Journal is a dream come true. Congrats and thank you, Mehmet Oz. What I got out of it, I got to appear on the Dr. Oz show. So who invented the MitraClip and when? Mehmet Oz, 22 years ago in 1997. Again, it's an innovation that is happening today, but it took 22 years to get to this point. So we can't get too complacent with the way things are. Kodak said they're in the film business rather than the imaging business. And where is Kodak today? Totally replaced by phone cameras. This is the original telephone, totally replaced, landlines totally replaced by phones that you hold in your hand that have more computing power than the original IBM Maniac computer in 1945. The corner bookstore has been totally replaced with online booksellers. Record stores no longer exist because everything is available online. And Blockbuster stores which sold home videos have been totally usurped by Netflix, all because they weren't innovative enough to see what was going to happen to them. And the yellow taxi cabs in New York City have been totally usurped by Uber. The Swiss watch companies don't think that they are in particular jeopardy, but my bet is on Apple here. So So if I think about my medical career, which started as a medical student, I was an intern in internal medicine at the University of Minnesota in 1973. Acute myocardial infarctions had a 1-month stay in the hospital because there was nothing you could do for them. Surgical hip operations had 6 weeks recovery. There were no such things as knee replacements. Acute leukemia, there was no cure. Cholecystitis had a 6-week return to work after open cholecystectomy. Heart transplants had gone from headlines to abandonment at every place except for Stanford. And there was no field of interventional cardiology. And heart valve surgery was rare at the time. All this means is that I'm pretty old. And this is what I looked like then. What's happened since then? The mortality from heart disease has declined by 50%. Total hip replacements are routine. Bilateral knee replacements are an outpatient procedure. Most leukemia is now cured. Lap chole is an outpatient procedure. Heart transplants and mechanical circulatory assist are now routine. And we have transcatheter heart valves, and I got a haircut. So we have an incredible legacy in the field of cardiac surgery. Can you put sound on, if it's possible, please? The final word, there's nothing more difficult to manage or more dubious of success than to initiate a new order of things. The innovator has enemies in all those who would profit from the old order, and only lukewarm defenders in all those who would profit from the new order. Anybody know whose quote this is? Machiavelli in The Prince. So my plea to you is don't get sleeping on the tracks, because innovation is happening all around you. And nothing is ever as easy as it looks. No sound? That's all right. You'll get the idea without sound here. So final thought, control your own destiny or somebody else will. Thank you very much.